Hello all, I welcome you to the Shanthalakshmiias Academy. In today's session, we are going to study about Aditya L1 mission in detail. So ISRO has seen back-to-back success following its Chandrayaan-3 mission. Within the days after that, ISRO has successfully launched the Aditya L1 mission. So the name Aditya L1 mission itself denotes that Aditya means sun in Sanskrit and L1 means Lagrange 1 point. So in this mission, ISRO is set to place a spacecraft in a hollow orbit at the Lagrange 1 point, which is located 1.5 million kilometers away from the Earth to study the sun. So this will be the India's first space-based observatory mission to study the sun and India's second space based astronomy mission after AstroSat, which was launched in 2015. AstroSat is India's first multi wavelength space telescope. The launching vehicle that we have used in this mission is PSLV C-57. The mission life is expected to be 5 years. So, to understand the objectives of the mission and the working of the payloads effectively, first we need to have an idea about the anatomy of the sun. So here, core is the innermost region of the sun where nuclear fusion happens. Two hydrogen atoms merge to form helium and releases energy. Next to the core, we have a radiative zone where energy is transmitted through radiation. Next to the radiative zone, we have convective zone where energy is transmitted through convection. So the core, radiative zone, convective zone together form the sun interior. Next to the sun interior, we have sun's atmosphere, which constitutes photosphere, which is the visible surface of the sun. On this, we can see the sunspots. Sunspots are nothing but darker and cooler areas where we can see higher concentration of the magnetic field. Next to the photosphere, we have a chromosphere, and to the next to the chromosphere, we can see the corona, which is the outermost layer of the sun. And we can also see the transition region between the chromosphere and corona. Transition region is a thinner and irregular area that separates relatively cooler chromosphere and much hotter corona. So if we need to arrange these layers from inward to outward, we can say that first the innermost region is core, then radiative zone, convective zone, photosphere, chromosphere, and the last outermost layer of the sun is corona. And we also need to have idea about the few flare activities that happen at the corona, such as coronal mass ejections, where we can see the sudden eruption of plasma and the magnetic field through the corona, and solar wind, where there was a continuous flow of charged particles from the corona. And the sudden release of energy in the form of radiation is known as solar flares. So next we going to discuss about the payloads which were placed on board. So in this mission we have 7 payloads that placed in the spacecraft. Those 7 payloads helps us to understand the sun's corona, chromosphere and photosphere. So the first payload and the most important payload is visible emission line coronagraph that can image the solar corona. The next payload is solar ultraviolet imaging telescope that can capture UV image of solar photosphere and chromosphere. And next we have SOLEX and HELOS that will help us to study the X-ray flares. Next to that, we have aspects and PAPA to study the solar winds and energetic ions. The last payload is magnetometer to measure the magnetic field. So out of all the 7 payloads, four of them, that is first 4 of them, that is VLC, SUIT, SOLEX and HELOS were used for remote sensing of the sun. And the last 3 aspects, papa, and magnetometer were used for in situ observation, that is, in situ study of the particles present at the Lagrange 1 point. So these were the 7 payloads that were present in the spacecraft. Next, Lagrange points. You might be wondering why we placed the Aditya L1 mission especially at the L1 point. So in order to understand this, first we need to know about the Lagrange points. So Lagrange points are the specific positions in the space where the gravitational forces of the two large celestial bodies such as Earth and Sun cancels out each other, such that any object that placed in this particular point will not tend to move or deviate from its orbit. So we can say that the Lagrange points are the parking spots for the spacecraft to remain in a fixed position with minimal fuel consumption. So we have 5 Lagrange points, that is L1, L2, L3, L4 and L5. L1, L2, L3 were located along the line connecting the two large masses, that is Sun and the Earth. L4, L5 are located at the apex of the two quadrilateral triangles. Among the 5 Lagrange points, the first 3, that is L1, L2, L3 were unstable, and L4 and L5 are the stable points. And also these L4 and L5 points are also called as Trojan points. We said that L1, L2 and L3 were the unstable points. What do we mean by this? Because any object that placed at L1, L2, L3 will tend to fall out of the orbit. So in order to maintain their position, we need to do the course corrections by firing the onboard thrusters that were placed in this spacecraft. So let us study in detail about the L1 point. We placed Aditya L1 mission at the L1 point because here we have the advantage of continuous view of the sun, and it helps us in observing the solar weather in real time. It was also currently the home to solar and heliospheric observatory satellite. The L2 point in the Earth Sun system is a strategic location for the spacecraft. It is a home to India. It is a home to the world's largest and the most powerful space telescope, that is James Webb Space Telescope. The L2 point offers advantage for the astronomy and helps us to have a clear view of the deep space. L3 point is not much of use, whereas at L4 and L5 we can study about the asteroids. Next, objectives of the L1 mission. The main objective of the mission is to have a deeper understanding of the star that is closest to us. Here it is sun, and helps us to study how its radiation, heat, flow of particles and the magnetic fields affects us. The payloads on the mission helps us to study the upper atmospheric layers of the sun, that is chromosphere and corona. It will also helps us to study about the source of coronal mass ejection. This mission also helps us have an idea about the magnetic field of the corona and what are the drivers of the space weather. It will also help the scientists to know the reasons behind the continuous flow of particles from the sun that led to the solar wind. Next, why we need to study the sun from the space? Because studying sun from the earth can't provide a complete picture about the sun's atmosphere, because earth atmosphere and its magnetic field act as a protective shield that blocks out harmful radiation such as UV light. We all know that the sun is the biggest source of energy and it supports all life on the earth. So studying the sun will help us understand the various phenomena that was happening on the earth, and it also helps us to understand more about other stars that were present. It also helps us in predicting space weather and mitigating the effects of solar phenomena on space technology. As we know, these space events can have adverse effect on communication satellites, communication networks, and power grids. From the prelims point of view, we also need to have an idea about the various solar missions worldwide. So, Solar Heliospheric Observatory. This is a joint mission of NASA and European Space Agency, launched in 1995. It helps us to study the sun's atmosphere and its interaction with the solar wind. Keynote is a Japanese mission launched in 2006 to study about the corona and the transition region of the sun. Solar Dynamics Observatory, it's a NASA mission launched in 2010, helps us to study the sun atmosphere in great detail. Then the NASA's most important mission that was launched in 2018 is Parker Solar Probe. This is the first spacecraft to fly through the sun's corona, helps us in studying the sun's atmosphere and its magnetic field. Then the Solar Orbiter is a joint mission of the NASA and European Space Agency, launched in 2020, helps us to study the sun from different angles, including from behind the sun. So let's have a look at the practice questions for prelims. With reference to the Aditya L1 mission, consider the following statements. The first statement says that it is the India's first space-based observatory solar mission, and the second statement is it was launched using GSLV Mach 3 launching vehicle. Third statement is spacecraft is said to be placed at the Trojan point in the hollow orbit. And the fourth statement is visible emission line coronagraph payload is used to measure the magnetic field in the sun's atmosphere. How many of the statements given above are correct? Option A, only 2. Option B, only 1. Option C, only 3. And option D, none. The answer for this question will be provided in the comments section. The PDF of this topic will be provided in our Telegram channel. The link for the Telegram channel will be provided in the description box. Do check it out. Thank you.